Hi, this is Coach Dorf. Let's look at a homework problem from section 5.5 on U substitutions. So this problem here, we're supposed to evaluate the integral of x cubed times the square root of x squared plus 1 dx. Now I chose this problem because this is an example of one where when you do the correct U substitution, you won't get rid of all the x variables. So you have to do a little bit more. So you can see how to do this process. This is the hardest type of problems, I think, from this section on U substitutions. All right, so to get started, I look at this and I say, what is going to be U substitution? Since I have that square root there, a good choice would be to let U equal what's underneath the square root. So I'm going to say, let U be x squared plus 1. All right, then we need to compute what du is. So taking the derivative of both sides, I'm going to get d equals 2x dx. Now this looks like it could be helpful because I have an x dx there, but in the original integral, I have an x cubed dx. So I don't have all of the terms there, all right? So to show how this works, first I'm going to bring the 2 from the 2x dx. I'm going to bring the 2 to the other side because I don't have any 2 as a coefficient on my original integral. So when I bring the 2 over, I have 1/2 equals x dx. So the original integral was x cubed times the square root of x squared plus 1 dx. Since what I have for du has an x in there, but not an x cubed, I'm going to factor out x cubed to be x squared times x to the first times the square root of x squared plus 1 dx. Now I can do some substitutions here. This x dx here is equal to this 1/2 du. All right, so when I do that substitution, I'm going to have the integral of x squared. Then I'll have the square root of u, and that's coming from my u substitution there. And so that gives me that. And then I have a 1/2 coming from the x dx. So writing that a little bit nicer, I have 1/2 the integral of x squared, square root of u du. We did everything right, but we still have that x squared. So what can I do? In this case, and in any of the cases that you would see like this, I'm going to look at my original u substitution, u equals x squared plus 1. What do I have after I did my u substitution? I have an x squared. Well, I can get an x squared from my u equaling x squared plus 1 by subtracting 1 from both sides. So when I subtract 1 from both sides, I have u minus 1 equals x squared. Now I can take that and substitute that in for my x squared. And when I do that, then my new integral becomes 1/2 the integral of u minus 1 times the square root of u du. This may look more complicated, but actually this allows us to solve the problem. All right, to do that, I'm going to rewrite the square root of u as u to the 1/2. Then I'm going to distribute that u to the 1/2 to both of the terms inside the parentheses. So now I have the 1/2 the integral of u times u to the 1/2 minus 1 times u to the 1/2 du. Getting that so that the terms only have one u term there, I do that by adding the exponents. So u times u to the 1/2 is the same thing as u to the 3/2, and minus 1 times u to the 1/2 is the same as u to the 1/2. Now I can use the reverse power rule to find the antiderivatives and solve this integral. So I have 1/2 u to the 3/2. I'm going to add 1 to the exponent, so I get u to the 5/2 and multiply by the reciprocal of that exponent, make that into the coefficient out front. Likewise, for u to the 1/2, I'm going to add 1 to the exponent, so that'll give me 3/2 and multiply that by 2/3 and add c. So now I'm going to distribute this 1/2 out front to both terms. And when I do that, 1/2 times 2/5 is going to give me 1/5 u to the 5/2. And then when I distribute the 1/2 to the negative 2/3, that's going to give me minus 1/3 u to the 3/2 plus c. And we're almost done. The last step is now to go back and do my u substitution reverse. So substitute in for u. Remember, u was x squared plus 1. So using u equal to x squared plus 1, substitute that in here, and I get 1/5 x squared plus 1 to the 5/2. minus 1/3 x squared plus 1 to the 3/2 plus c. And that becomes my final answer. All right, hope that helped.